force P acting along a smooth inclined plane can support a weight W1, whereas if the same force acting horizontally can support a weight W2, then prove that P squared is equal to W1 square minus W2 square. So to enter this question, we must understand the diagrams. What diagrams are saying. The first case is that P is acting horizontally. Say if this is the inclined plane, and if P is acting along the plane, then obviously it is supporting W1, and the reaction of that is R1. And this is angle theta. So angle between P and R1 will be 90 degrees. And the second diagram is that when the force P is acting horizontally to this inclined plane, the same inclined plane, and in that case it will support W2, and obviously the reaction will be 90 degree to the plane, and I'm calling it as R2. So these are the two diagrams. So using these two diagrams, we will be doing this question. So now, can you analyze that this is the first diagram? Now, this angle is, if I put a dotted line, this will be 90 degree. So clearly this angle will be 90 minus theta, and this angle will be 90 plus theta. This is 90 degrees, and clearly this whole angle between R1 and W1 will be 180 minus theta. So applying Lami's between W1 and P, so W1 upon what? Sine 90 degrees, and is equal to P upon sine this angle. And we can leave R1 because we are least concerned with R1. So if you want to write R1 upon sine 90 plus theta, but we are not interested because the concept is only between W1 P, and in the second diagram it is W2 and P. W1, that is equal to P upon sine 180 minus theta is sine theta. So W1 is equal to P cosecant theta. This is equation number 1. Now coming on to the second diagram, and now for the second diagram, if you concentrate the second diagram, this angle, because this is horizontal, this is theta, so this angle is also theta. This is 90 degrees. So this angle is 90 minus theta, because this is 90 degrees, this is theta, and the whole angle is 180. So it is 180 minus 90 plus theta. So this is 90 minus theta. This angle is 90 degrees. So now, what will be this angle? So this angle is also 180 minus theta. Okay, because this is 9. This is 90, this is theta, this is 90 minus theta, and this is theta. So the angle between W2 and R2 is 180 minus theta, because this whole angle is coming 180 plus theta. So if we subtract it from 360, it will be 180 minus theta. So same way we apply Lami's, but this time in W2. So what is W2? The angle opposite to that is sine 90 plus theta, and P upon same sine 180 minus theta, and there is no need to apply the angle or ratio with R2, but still if you want, this is R2 upon sine, the angle between W2 and P is 90 degrees, so I'm putting 90 degree. So same way the logic is only between W2 and P. So W2 upon cos theta, and this is P upon sine theta. So W2 is coming Can you connect cosecant theta with cot theta? We have one identity which is cosecant square theta minus cot square theta is equal to 1. Now we have W1 which is equal to P cosecant theta, that is equation number 1. So W1 square will be, so I'm calling it equation number 3, and W2 is this equation number 2 is now turning to equation number 4. So now if we subtracting fourth from third, we can use the identity cosecant square theta minus cot square theta is equal to 1. So we get W1 square minus W2 square here, and this is P square cosecant square theta, and taking P square common, which is 1. So we have proved that P squared is equal to W1 square minus W2 square. Thank you very much.